Okay, hello everyone. Let's go ahead and take a look at area between two curves. Okay, let's just go ahead and take a look at example number 1. Now this is the graph associated with example number 1. It says f of x is equal to x plus 1 on the interval from 0 to 2. Okay, so what I've drawn here is the function f of x is equal to x plus 1. And notice that it went from 0 to 2, and I used dotted green lines for that. Okay. Now, what if I wanted to go ahead and find the area that was bounded by f of x and g of x, and let's say that g of x is actually going to be equal to 0 in this case. So y is equal to g of x. Oops, sorry. G of x is equal to 0. Okay, is the x-axis. And now notice that what we do is we just go ahead and actually determine what the integral is. And so the integral would just be f of x plus 1 from 0 to 2. The integral of x plus 1 d of x from 0 to 2. Now the reason why I wanted to go ahead and bring about this whole fact about g of x being equal to 0 as the x-axis is because now we're going to try to actually determine what the area is between two curves. And what we want to do is we want to actually identify what those two functions are. So the x-axis will be actually looked at as g of x is equal to 0. And the f of x is actually going to be this function here. So what I'm going to do then is to actually go ahead and talk about the area that is actually bounded by the two functions. I'm going to use a rectangle. Okay, and what I've done here is I've drawn this rectangle in black. Now, notice that wherever this rectangle is between 0 and 2, the top of the rectangle is always touching the curve f of x. And the bottom part of the rectangle is always going to be on the function g of x equals 0. So notice then that this part over here is going to be the top function. This part over here is going to be the bottom function. Okay? So what I can say then is that the height of that rectangle is always going to be f of x minus 0 because g of x is actually going to be 0 in this case. So in other words, if I go from here to here, of course, the height of that rectangle is actually going to be 2. Okay, and then if I go over here, the height of that rectangle is going to be 3. So basically, if I just go ahead and use f of x, I can find the height of the rectangle, which is what we've been doing all the time when we actually differentiated, when we integrated definite integrals. So the area, in this case, we can just go ahead and say that is the definite integral from 0 to 2 of f of x minus 0 d of x, and of course that's just f of x d of x. Now, things start to change though once we go ahead and no longer use g of x equals 0 or the x-axis as the bottom curve. Okay, so let's just go ahead and say, for example, that I use this curve here, and let's say that this is g of x is equaling -1. Okay, so now when I actually go ahead and think about this area that I'm trying to calculate, the area actually extends down into this area over here. Okay. And in addition to that, the rectangle that I have, the height is actually this long now, okay? Because this value over here is the bottom curve. It's the bottom curve. So now when I go ahead and take a look at the area bounded by f of x and g of x is equal to -1, and here's g of x is equal to -1, the height of that rectangle is now actually 1 unit longer than it always was before with this example here. So what I have then is that if I go ahead and take a look at this top function, again, notice that if I go anywhere between 0 and 2, the top function and the bottom function are always going to be established as the same functions, the top one being f of x and the bottom one being g of x. Therefore, the height of that rectangle is going to be this value minus that value. Okay, so what I say then is that the height of the rectangle is going to be f of x minus -1 because that's the g of x value. So notice that this is just going to be f of x plus 1, which means that the height of the rectangle is always 1 more than it usually was in the previous example. So what I can do then is if I wanted to go ahead and evaluate this area now, I can go ahead and say that the area is going to be equal to the integral from 0 to 2 of f of x minus a -1 d of x. Okay, and if we wanted to go ahead and simplify that, of course, that's just f of x plus 1. Now, in general, what we want to do then is we want to say that the area of any area that is bounded between two curves is always going to be established by taking the integral from a to b of the top function minus the bottom function d of x. okay, as established by the rectangle's height. So that's why it's going to be absolutely essential that we actually go ahead and get a graph of this so that we can see exactly which function is actually going to be the top part of the rectangle and which one is actually going to be established by the bottom part of the rectangle. Okay, and then what we can do is we can just go ahead and find out what that is by using our rules.